So folks, welcome to the Planning and Design for Climate, a Paradigm Shift session. This is the last session of the day. Thank you all for sticking with us throughout this really jam-packed day of great content. Here is the description and learning objectives. If you are applying for AIA continuing education credits, we will follow up with an email. We know that you've attended this session. We will send you an email and ask you to fill out a form with your AIA numbers, and that will help us to help you complete your continuing education credits. And with that, I would also like to note that we will have a question and answer at the end of this session. If for any reason we don't get to all of your questions, we will be archiving all of the questions and ask the presenters to write in a written response, and we will archive that dialogue on the CarbonPositive website after the teach-in. With that, I will turn it over to your moderator, Kira Gould.
Thank you, Vince. I'm Kira Gould. I'm a writer and communications and strategy consultant with Kira Gould Connect. I also work with AIA's Committee on the Environment. I'm really excited about the momentum that is afoot right now, both the technical innovation and also the cultural change of heart that's going on. And we have a really great session today. We are going to try to fit 3 fantastic projects into 40 minutes. So I'm going to jump right in to do quick introductions of all 3 of the speakers, and then we'll start with our first one. We are first going to hear from Alastair Reilly, who's a design partner at William McDonough & Partners. His focus is on research-informed design and allows him to find innovative, sustainable solutions to complex building types. He's led design on many of William McDonough & Partners' most innovative projects, including YouTube's headquarters, Park 2020 in the Netherlands, and Agro Food Park in Denmark. His experience includes large-scale high-rise and mixed-use urban developments, campus workplace, hospitality, and residential projects. And he's going to talk about CoLab for HIT construction. We're then going to hear from Rodrigo Carazo about Casa Carazo, the home of Carazo Arquitectura in San Jose, Costa Rica. And his work has been closely related to sustainable design as well as the exploration and reinterpretation of spatial programmatic relationships. The main focus in his studio work today is biophilic design, which he develops through a personal design methodology focusing on site responsiveness and on positive effect on perception and well-being. And after that, we will hear about a medical office building from Duncan Griffin, who's the managing principal of HDR's architecture studio in Seattle. Duncan's practice focuses on bringing regenerative design principles to diverse clients with projects in health, community, and education typologies. He's particularly focused on creating a positive human experience in the built environment and finds synergies that make projects more efficient and less expensive to operate. Successful outcome for him delivers healthy experiences for building occupants, a flexible building infrastructure, and facilities that serve the community through reduced water, energy, and carbon impacts. And with that, I would like to turn it over to Alastair to kick us off with CoLab.
Great. Thank you. Let me get this going. Thanks, Kara. So as Kara mentioned, my name's Alastair. I'm a design partner at William McDonough & Partners. I'm going to talk a little bit about CoLab, a project that started in 2015. With all of our projects, we like to think about what it means to be a building like oxygen, sequestered carbon, fixes nitrogen, accrues solar income, and try and think about these carbon positive behaviors as we approach design of a project. CoLab is a collaborative workspace for HIT contracting. They're general contractors, headquarters in DC. They're just outside of the district on the Beltway, and they have a headquarters, and they had this leftover site they came to us with in 2015, which they had designed to be kind of a sports, basically a gymnasium for their employees. They came to us and said, you know, we'd like to think about what it would mean to do a research lab for clients and for the teams there. And they had an existing dilapidated house. This is sort of a transitional area, walking distance to the metro with kind of mid-rise housing coming in. And this is a light industrial kind of working zone, literally a junkyard across the street. So the idea was to take this Untitled design, which was basically a rectangular box. It had great orientation, east-west with sudden exposure. So we did a quick solar analysis to see, what kind of solar income we had on the site to work into this program. So we approached it with the city of County of Fairfax. We were limited in the footprint, what we could do. Again, the orientation was good. We're literally on the north parcel of the site. The first thing we said, what about mass timber, thinking about carbon story, also thinking about erection and modular construction, because it's a very tight, restricted site, optimizing the glazing and the facade for views as well as insulating values. And then again, integrating this PV array, which would become, a roof terrace and a potential R&D piece as well. This is the plan we ended up with. It's really double height R&D labs where they do mock-ups, collab meeting spaces, and then conferencing working areas as well as virtual construction. The roof terrace has integrated PV as well as they've got, we built some skids platforms that they could test mechanical systems as well as green roof and other technologies as they continue to grow. As we approach this, we did look at kind of a baseline building, steel and concrete, and then a hybrid. We were working with Bender Holtz at the time for a steel frame with CLT slabs. And then we quickly went to an all CLT structure, glulam CLT panels. And part of that, again, was time and savings for erection, again, for a tight site and having it all pre-engineered, brought in from offsite. And then this story about, carbon, that we could actually have a structure that sequestered carbon in the structure. We did this with Revit, with BIM. We used Tally for early studies for the life cycle analysis, and we actually did Athena as part of the COAT awards in that. I want to just note all of these are life cycle, and one thing they do not take is, the next use, because again, we're sequestering carbon in that wood structure, and the idea that this building is designed to be disassembled. These are high value glue lambs as well as cross-laminated timber panels that have high structural value and reuse material. If you think of, buildings from Soho or in the West Coast with some of the old Navy buildings, that they have future assets. So the idea that this building could be assembled on site, but taken apart and reused later or reassembled at a different site in the future. Another positive impact was the cost savings on not coming in and painting, cladding, fireproofing, introducing borates and other nasty things to do that. So we, our product was what we got and used that as the finished material as much as we could. From an energy side, we started with a highly insulated envelope, again, optimized glazing for the south, and we do have some east and west that we had to do some external shading to reduce those energy loads by 50% from a baseline building. We did do an HRV mechanical system, which enabled us to do a different system for the high bay work areas and then for the office space, and actually shut those down in different sequences as the building's used. When we started, as I shown, was covering the entire roof energy loads, in this case by the energy performance of the skin and the energy efficiency of the panels. These were sun power panels, and just the efficiency had gone up, so we were able to reduce that by a third. But with the installed power here, we're able to create more energy than we're using in the building. This is a view of some of the VRF systems in the high bay workspace where they have some of the mock-ups and modules. In some cases, it's an operating room to studying new structural systems and material systems. Regarding metrics.
Alastair, you've got 1 minute.
Okay.
Sorry.
We're about 50% below a conventional building. Again, with the integrated PVs, we're producing more energy we use, and we've got an integrated battery system for backup. The other big feature was safe, healthy materials and using cradle-to-cradle protocol to assess and peer review products. We did go through LBC and have a material pedal for materials. And the next step is we're looking for our energy reports. We just went online the end of last summer, so we're hoping we'll be net energy positive certificate by the end of the year. Some of the mock-ups within the space. They do tracking, monitoring. We're monitoring all the systems now. Part of the site, we were limited again by parking realities with the county, and we did introduce CarbonCure in the concrete mix for the paving in the parking lot, which allows for fire as well as heavy-duty truck access. Now I can finish up there.
Great. Rodrigo, you're up.
Just a second. Okay, so thanks, Kira. Just to go over a bit about our project, Casa Carazo is our firm's office, and we just finished the construction last year, and it's a project based on expressing our ideals and our philosophy of work, and where we see our practice going, and what we can offer to our clients and to the project itself. The project is a double project. So we have restoration of a 90-year-old house in the center of the city, and a new building construction, which is the main workspaces for our firm, all related to 4 main low carbon footprint design strategies. So the first strategy has to be with location. The second strategy with low energy consumption. The third strategy, low embodied energy materials, and the fourth strategy is related to carbon sequestration. The project itself, it's an architectural studio. So we have a main studio workspace, meeting areas, mezzanine area, common areas, and different innovations that we have added to the project to look for new ways and to perceive a workspace. So we're looking to the future of a workspace that it's not based on technology or not only on technological solutions, but on passive design, and how we can have a very low energy footprint construction that makes people feel good and work better. So our first strategy has to do with location. The project is built in the city center, San Jose, Costa Rica. Our capital has followed the bad example of many other places in the world of suburbanization, and most of the development happens in suburban areas. And we decided to invest and develop our new office in the city center, where we already have a lot of infrastructure in place that allows for that amount of carbon footprint required to do new infrastructure somewhere else to be saved and utilizing the existing one. And also, one of the important things also is that the center of the city, or the public transport or mass transport that we have, which is mainly bus, all goes to the center. So it's also a very easy place for our co-workers and collaborators to get to without double, triple trips, or with the possibility of taking public transportation, which is not the norm in Costa Rica. So that first decision was very important in terms of our project to reduce our footprint. So it's as I told you, a 90-year-old house that we have renovated on the outside and completely done a new building on the back part of the property. The second strategy we use is low energy consumption based on passive design through natural lighting and cross ventilation. So all our roofs and facades are thought of with a high R coefficient or a high level of insulation. All our energy savings are about 40% more efficient than base case based on EDGE certification, which is the certification our project holds. So we have greatly diminished the consumption of energy in our project. And well, here you have a main or a picture of our main space. It's fully oriented. The windows are fully oriented to north and south conditions. So we have always indirect lighting, and it works with a natural ventilation system. Costa Rican climate can be very tough, especially well, for the whole of the summer and in the mornings of winter, where it's or rainy season, where it's very humid and hot. So having a cross ventilation system allows us to have a cool and less humid workspace that is comfortable for everybody at the firm. Here's a diagram of our project. So basically, for insulation for keeping the heat out, we've designed a green roof, experimenting with high level of angle on the roof. Costa Rica, it rains a lot, so you need to evacuate water relatively fast because it's a lot of quantity. So we've kind of mixed the traditional flat green roofs with our Costa Rican necessities and created also a park or relaxation space for our co-workers. And the cross ventilation scheme works connecting two inner courtyards that move the air from one side to other. We have already been here through a full summer, and the place is actually cold during the day. So our planning has worked as the idea planned. Again, this is another picture of the workspace, looking at that indirect lighting. We've also used full LED lighting for certain hours of the day. We try not to have the light on for pretty much most of the day, because we can handle our needs with indirect illumination. Additionally, there's some internal climate control systems or practices that we've been using with vertical gardens that allow us to keep also climate or temperature down. So
1 minute, Rodrigo.
Of other pictures. And additionally, we have a selection of low embodied energy materials. We've used a lot of wood in finishes and as well as a structure, having a 64% more efficient building than the base case of a similar office. So some of the using of that material. And finally, we have worked a lot in the terms of creating more green space to collaborate with carbon sequestration through green roofs, inner courtyards, and vertical gardens. We've increased our original green area by 318%. And all this together allows us to have a project that is 70%, that reduces 70% the carbon emissions, coming from 9.8 tons per year to 3 tons per year, with a combination of the fixation of carbon through materials and the fixation of carbon through the vegetation we have in our project. So that's a bit of an idea of our project. And again, thank you for the invitation to share it with you.
Thank you, Rodrigo. Duncan.
All right. Can you see my screen?
Yes.
Yes, we can.
Very good. So I'm Duncan Griffin, again, managing principal of HTR's Architecture Studio in Seattle. And really, I wanted to share with you at the beginning here, our practice is focused on regenerative design, which for us is a project-tailored approach to regenerating conditions which support life in our communities and ecosystems in the areas you can see on screen. And today, I'll be sharing with you a case study which demonstrates methods to address carbon goals, while the project also incorporates aspects of human health, community, and air. So the project is a specialty medical office building for a confidential client in an urban setting, which is designed to be net zero energy and achieve carbon balance. And the project is in a pre-design phase. So it consists primarily of gathering spaces and cellular offices for care providers. So it was designed to provide healthy air to occupants in a once-through passive capable distributed mechanical system using stack effect buoyancy and waste heat to drive air movement through the building. It has been modeled by our MEP partner to operate at an energy use intensity of 18 kB2 per square foot year, with air systems operating passively for up to 25% of open hours. Note there are solar panels on the roof, walls, and fins. And so here you see the energy breakdown as calculated by our engineer. And based on being in a mild climate, this is ASHRAE climate zone 4C, perimeter fan coil units with filtration introduce air into the rooms either at the ceiling or under the floor, which is then drawn up through that central light court that you see here. And what we've done is to calculate using this energy matrix, which we developed based on the project area, the typical benchmark, the code baseline, the performance that we were able to get to, and then the solar required to achieve net zero energy. And so that includes the energy costs and the associated atmospheric carbon in metric tons, the energy savings, and ultimately the square footage of solar panels required, which is about 32,000 square feet. And notably on the roof as well as on the walls. So here you see a build of the project presented in a cutaway perspective, showing the foundations and lower levels in concrete, which are offset with steel and wood columns and beams with cross-laminated timber decks that use poured gypsum acoustical floor coverings, building up to the photovoltaic roof and curtain wall incorporating additional panels. And so this diagram shows the carbon emissions that are associated with shell and core materials. Here indicating the carbon emitting materials, and then here the wood materials. And as noted earlier, this assumes or builds in detailing for disassembly, so that it is assumed that wood products would largely be salvaged, recertified, and reused in future buildings. With a small floor plate and 10 floors, the surprise here is the curtain wall accounts for a large percentage of the carbon footprint. You can see there is a net imbalance when we add up all of the sequestering materials and emitting materials of I think 19 kilograms of CO2 per square meter, or per square foot, excuse me. So we went to our structural engineers and asked for their help in figuring out how do we bring this design in at carbon balance. They did an EC3 analysis and identified really that there were three material groups, as I think we all are. It's unsurprising that concrete and metals in the buildings account for a significant carbon footprint that can be reduced, but also that the openings and glazings, curtain wall, is a big target, and again, bigger than usual. So we looked at the life cycle analysis of the life cycle stages of steel, right? And have identified that it's really the reforging of recycled steel that can drive the carbon footprint. So our task was to find environmental product declarations that are in non-carbon-based electricity, which dramatically reduces the carbon footprint of this material. Likewise, in concrete, we've identified concrete has the largest carbon footprint of any building material. Partly as a result, there are a number of solutions under development to bring down its contribution, such as a fly ash or slag substitution, changing out of the aggregate for a manufactured CO2 seeded limestone, as well as an option to blend CO2 into the concrete mix in the pour. Lastly, the building skin, which is comprised of many materials, including aluminum, glass, plastics, and coatings. The simplest modification one can make based on environmental product declarations available on the web is to change to steel and stainless steel as the base building material. Note there are innovations in aluminum that may change this in the future, but I'm not aware of any that are in production. Another important material consideration is the insulation, where carbon sequestering material choices are increasing. So once we substitute these materials and reduce the numbers accordingly, we're able to achieve a carbon balance and a carbon sequestration of about 4%. And note, we do not believe that this approach necessitates a first cost increase, as it is likely to construct this model more quickly than a building in which concrete curing can delay the fit out. This approach and these tools are available as you consider what you can do to make a difference in your project. And for us, ultimately our goal is to address carbon on every project we do, developing a process that can be replicated so that we can start to deliver zero emission buildings and complete really the goals of our regenerative framework. And why do we do this? And here it is. We are hurtling headlong into the future. Down a road we think we know, but this is not the highway we grew up riding down. We think we know what is over that ridge ahead, a beautiful destination, but in 2015 and 2018, it was a wall of fire. We all have a role in reestablishing conditions that support ongoing life on this earth whom we cherish. This is an emergency. We are intentionally sharing the tools we developed with you to help you move buildings from harming to healing the planet. It needs all of us, and we're here to help. Thank you.
Thank you, Duncan. That was great. And thank you, Rodrigo and Alastair. I really appreciate everyone moving so quickly through those projects. There was actually, obviously, a lot more we could have talked about with each one. Vince, do we have questions from the group, or shall I ask some of mine?
I think, go ahead and ask yours, Kira. I think you answered the 3 that came through during the presentation, and it's not for lack of participants. It's just, I guess.
Yep, I see we have a good group, and thank you everyone for joining late in the day. Okay, so I do have some questions, and I thought maybe we could jump back to Alastair to start. Well, and all 3 of you have talked, I think it'd be great to hear from all 3 of you about the kinds of tools that you recommend that practitioners be using, especially for carbon. But I wanted to ask Alastair to start with, if you could talk a little bit about how, for your teams, how concepting starts, particularly with respect to carbon. I mean, how you start, do you start with carbon positive as kind of a baseline or a goal, or how does that work for your teams?
I think we do. I think we need to start there. So certainly we do, and I think that with Bill's vision of a building like a tree, we do like to start there, and that's always been, I think, the case on the energy front, and certainly starting with passive strategies, right orientation, high performance skin, glazing. But now, as Duncan said, we're really deep into, carbon emitting materials. Again, the timber has a positive impact, but it is coming down to doing these life cycle analysis for, say, aluminum versus, even anodized aluminum versus kind of our finished aluminum. There's real impact there. So we are down to, the molecule, looking at those different things. As far as tools, we start early with SketchUp and Safari, just from an environmental piece, then quickly get into Revit. As Duncan mentioned, Skanska has released EC3, which has EPDs, environmental product declaration sheets. So I think there's an amazing amount of open source material to dig into these things early on. And again, it's for us, as all projects, it's cost and money. So trying to get these early and trying to show what that positive impact over the long term is critical.
Right, that's great. That's really helpful. And actually it is because, it's great that there are so many tools. I do think that many firms find that in and of itself a little overwhelming. So it's really interesting to hear from teams about which tools they're finding, particularly valuable, particularly for different scales of projects and things like that. So thank you for being specific about that. We do have a question from the audience about, Rodrigo, about your project. Taylor Lavender is wondering, in reference to Casa Carazo, could we hear more about the green space? It looked like there are canopy trees on or directly adjacent to the building. Could we hear more about how these were incorporated, root system sizing, water, carbon sequestration concerns?
Okay, yeah. Well, what we tried to do in our roof park was to go to the limit of what has been done in Costa Rica. So we tried the most slanted roof park in the country. There's nothing even close in terms of angle, to see what happens with heavy rains and to work with anti-erosion systems for our growing medium. In terms of the trees, what we did platforms, and we settled the trees in big planters with the right type of earth or soil, as it is very different from the other green systems growing in the roof. So all the system is artificially irrigated in summer with drip irrigation, and we have a lot of rain here during the rainy seasons. That's not an issue for more than half of the year. In terms of carbon footprint, it has really helped us because it's a big insulation system that takes pretty much all of the heat of the roofscape from going into the building. And it's also on the other side, it's vital space for us because we really believe that the good lifestyle or quality of life that being around nature gives you has to be involved also in workspaces. So that space up there is next to the dining area or the lunch area. At the end of the day, everybody, if it's a sunny day, has lunch outside, and it disconnects you from your day-to-day pressure. So it's a mixture of sustainable construction, low carbon footprint, but most importantly, higher quality of life and workspace.
That's great. Thank you, Rodrigo. I have a question from Helen Pierce. Clearly, all of these projects, this is a good one, had clients who are already on board. Certainly that's true in your case, Rodrigo.
Yeah.
Can you talk about the strategies you've used with an average client who needs some help getting there in terms of the intention of the project? Duncan, maybe we could start with you on that one. I'm sure you've had those clients.
Sure. Sure. Thank you. Yes. And honestly, I on the journey through meeting with clients who were skeptical and clients that aren't interested, I found that going all the way to the end and presenting a net zero energy option initially to our clients changes their framework. It changes their perspective because it becomes an object of desire or a strat. If they can make that claim about their building, they're very interested because of the sort of absolute nature of it. It's not a percentage reduction or someone else's program. It's their building that they operate. So the net zero energy matrix is something I had developed for every client, and that helps many of them to get much farther than they would have gotten otherwise. Mm-hmm. And of course, it's all about case studies of the strategies that we propose having been used successfully in other buildings, and even knowing the contact information for the facility manager at those hospitals or other buildings where they have the chance to really confirm the strategies work.
Right. That's great. Thank you very much. We have another question from Leanne Pfeiffer who says, who's asking about if you can discuss the relationship that you have with your mechanical, structural, and electrical engineers and how early they're engaged in the energy modeling and other parts of the process. Maybe Alastair, would you like to start the answer on that one, and maybe others will want to chime in?
Sure. Yeah. For us, I mean, that integration with the engineering design team for CoLab, we work with Gale and Stangle Engineering, who's a small firm but high performance. So we are doing energy modeling very early. And as Duncan said, I think in our first, if not second meeting with HIT, we came in and said, penciled out what energy positive looks like. And as I said, from cost and efficiency, the project started in 2015 and we went online the end of last year, and we went through multiple, value engineering exercises, et cetera. So the cost was critical as well. But I think that early connection, obviously passive strategies, but integration with engineers. The other one on the wood front is there's quite a few mass timber firms, so getting early insight from different manufacturers, because each system has a unique capability, so understanding some of the engineering capacities as well.
Right. Duncan or Rodrigo, do you want to chime in on that one, those early relationships and what kind of modeling you're doing up front?
Sure, I should let Rodrigo go.
Okay.
I'll add up onto that. Basically, we start with our consultants, engineering consultants, since the beginning of the design process. Of course, this specific project is for an architectural firm, and we're our own clients. So we were very specific on what we wanted and how we wanted to reduce the amount of material on site. And it resulted in several types of decisions of the steel we used, high strength steel and other issues that allowed us to reduce the amount of material. In terms of energy consumption, our condition is very different to temperate climates like you may have in the States or in Europe or wherever. And we have the facility or the good luck of being able to be outside and inside all the time. So definitely our interrelation of energy consumption was more related to artificial lighting and how to use the most efficient low consumption fixtures. But most of the climatization, it's done 100% through passive design.
Right. I have one, we're bumping up against the edge of our time already. And I do have one more question that I wanted to ask. And Duncan, maybe you can start an answer, and if others want to add in. We have an audience member asking about some of the key challenges in creating a carbon positive project. And specifically, they're asking about the cost implications of switching to carbon sequestering materials and what kind of pushback you might have gotten from clients along the way. Duncan, I think you might be able to speak to that one a little bit.
Yes, thank you. We have the great benefit of having a practice that's in British Columbia. And so there are very strong motivation on the client's part to build in wood there. And so we have some case study examples where building with cross-laminated timber actually shortened the construction period, reduced the depth of foundation because of reduced weight, and delivered a building that did not cost more ultimately for the client. And it was completed quicker. And so those become desirable for clients as well when they hear that it's possible. I agree with Alastair. The supply chain is very important, and making sure that you have available bidders and that you can work with the procurement process of your client. I think that those are also some challenges associated with this kind of change in the way that we do buildings. But there's a very strong embrace of this technology of moving back to wood products, particularly if they can be done in ways that keep forests healthy and maintain a soil sequestration of carbon. So no, I've found that that's not actually the challenge. There are technical challenges that we have to overcome.
Right. Alastair, did you have anything you wanted to add to that? This is our last question, I think.
Yeah, no, I think I'd echo Duncan's comments. We are seeing, you know, larger scale. We're doing some good sized projects in California where mass timber is cost competitive with steel. For us, even with all of our clients, cost is still, you know, an issue. But I think, as Duncan said, if we can show this path to positive, you know, when we look at lead platinum, in this case, LBC materials, those things have impact. But to start to talk about positive impacts and beneficial buildings, there is a bit of a mind change there too. And I think all of it is a hand-holding exercise. For HIT, this was, you know, a big stretch for them. And again, it was a cost stretch, and we went through multiple iterations to get there. So it's a lot of hand-holding, a lot of, you know, push and pull to do that. But I think once you can see these things are possible, you know,
right,
you can do it.
Rodrigo, did you have anything you wanted to add on to that one? I think you're muted. Oh, there you go.
Yeah, I think, well, for example, this project didn't go, it has a normal cost for an office a project in Costa Rica. But the main thing here is that we have three big bonuses on this type of construction. The first one is that we were able to access better financing for the loan for the construction because of having a low energy consumption or low energy footprint project. Second of all, on the long term, our maintenance costs, as you saw on our savings, are going to be huge. We pretty much spend the same as a small house and have an office here. And the most important thing is that people are happy and more productive, and that's going to be better for the business. And if we can show that to clients and other people, I think that's the way to go. Having a better spaces where people work the best, and especially in service or consulting companies, that human resources is the main resource or the main cost of operation. So I think those three things more than justify the costs related.
Great. Thank you so much, everyone, for joining. That is all the time we have. That seemed impossibly fast to me. But I just wanted to say thank you so much for being here for the last session of the day, and remind everyone to tune in on September 17th for the Europe, Middle East, and Africa teach-in, and on the 22nd for Asia Pacific, and Oceania. And there will be follow-up information at the website. So please visit there. And thanks again. Really appreciate all the time that our presenters put in today.
Thank you, everyone. And just to note that there will be one last section of tool demos available here at the end of the day. Please go to the CarbonPositive website for the agenda to click on those links if you'd like to watch any of those final tool demos. Thank you all from Architecture 2030 so much for joining us for today, for all of our wonderful presenters and moderators. This concludes the end of the main content.